So Australia has 11 species of stingless bee. We actually have about 2,000 species of native bee in Australia, but only 11 of these are what we call eusocial species, and they form large colonies. So 3 of these we tend to manage for pollination. The one we're looking at today is Tetragonella carbonaria. It's the most commonly used. It's distributed from around the Sydney region or just below, right up the east coast of Australia. This is important because often the European honeybee is used for pollination, but there are a number of limitations to the use of that in Australia. For one, it's an introduced species, it's not native. It does sting people, and that poses a health risk to some workers. There's potential for the honeybee also to suffer incursions from things like varroa mite, which are really destructive to the colonies. There's a lot of talk globally about declines in honeybee colonies. Often this is associated with things like the varroa mite, which attacks colonies and basically decimate those populations. Stingless bees are a really good alternative from that point of view. We can keep them a lot healthier, and because they're native, they've co-evolved with a lot of our plants as well. And today we're going to look at some of the work we're doing on strawberry crops.
Part of my research is looking at the efficacy of stingless bees. Can they effectively pollinate the strawberry plants? To answer these questions, we bag some flowers to exclude the bees, and then we have open flowers where the flowers have unlimited visits by the bees. The results so far from the fruits I've harvested, I can tell you that the stingless bees are very good in pollinating glasshouse crops. Another part of the research that we are looking at is how many of these visits is enough to give us these well-shaped fruits. So we are looking at 1 visit, 2 visit, 5 visit, 10 visit, 15 visit. We also factor in the duration that the bees spend on the flower, as well as their behavior. And so far, 1 visit, some are well-shaped, some are not. 5 visit, 10 visit is enough to pollinate the strawberry plants. Another aspect of the research we are looking at is the effect of having the bees in the glass house exposed to one crop for a long period of time. Does it have effect on their health? And for us to be able to answer these questions, we took samples of the bees before we brought them into the glasshouse. And here in the glasshouse, we are periodically taking samples of the bees where we are going to analyze their gut microbiome to see if the fitness level has reduced as a result of being here in the glasshouse and exposed to one crop. So far, we haven't noticed decline in their health.
So smart glass cladding has been suggested as a greenhouse cladding to thermally insulate the greenhouse. We found that the stingless bees were not affected under the type of smart glass cladding, and this was very interesting to us because the smart glass claddings actually prevent 99.9% of UV light. Previous studies have found that honeybees rely heavily on UV light for their orientation and navigation. So we think that the stingless bees we're looking at, they use landmarks, colours and shapes to effectively find their way around the glasshouse. We also found that there was a significant difference between the activity levels on each side of the glasshouse. So this would suggest that the east side of the glasshouse would be a better place to put your colonies for crop pollination.
We don't just want to show the horticulture industry that stingless bees are able to pollinate crops in the glasshouse. We also want to show them how to effectively manage these bees so that they can continuously use these bees sustainably to get high yield crops and well-shaped fruits. To give the horticultural industry the efficacy aspect of these bees, as well as how to effectively manage them for more sustainable, productive and sweet fruits.